Hi friends, a very good morning to you all. Hope you are having a great day. This is Madhumohan Kumari and I am here to share my experience about the project which I have done in this SEM, and the project name is Modeling of the Diameter, Intensity and the Temperature Profile of a Chopped Circular Source. In this project, I have taken the source as a star. As we see in the news or in the today world, scientists have found out many stars in the sky, and they also found the diameter or the temperature flow in the star up to whatever they want. And I have taken this project because I am interested in astronomical ones like the sky, the galaxy, star, and the universe, how the Earth will work, and the other planets will attract the sun. Coming to know about my project, I want to thank my supervisor, Mr. James Maxwell. He explained me how to find the temperature radius and the intensity. Like before, I don't know even nothing to find how to find. Like I really felt very bad. Like I have taken this project, how to I don't know because I don't know how to find the temperature radius. How I can find the formulas over the net and the PDFs from the library and all those. Mr. James helped me in finding each and everything. Like he explained me each and every point wherever I got uh, some of doubts and all those. He explained me clearly how to find this temperature, and he also told me to search some of the papers, and he told me he explained me in a different way. The main aim of the project is to find the approach in finding the diameter, the intensity of the star, and the temperature profile of a particular star. Like here, I have taken the example of the star as named as Rigil Kentaurus. Like this is the star that has already been calculated the radius diameter by the scientists. The reason I am taking the star Rigil Kentaurus because I want to check my values after finding out the from the formulas, like whether they are near or they are far, or whether I have right or wrong about this project, like finding the uh, formulas of temperature, intensity, or the radius. The equipment we have used in this project are the camera, the telescope, the laser beam, and the optical chopper. The camera is used to take the pictures of the star while focusing. The telescope is used to detect the star from the far places like Earth, and the laser beam is used to pass the wavelength through the optical chopper. And the last one is the optical chopper, which uses to chop the star as we focus from the telescope. The main objective of this project is to measure the intensity of the star as the optical chopper passes through the star over several times, and there is a laser beam which is used to pass the wavelength through the star and to detect the radius of the star, and the two color pyrometry is used to detect the temperature of the star. In order to find the temperature, the diameter, and the intensity of the star, first of all, we need to know what is meant by two color pyrometry. Like we need to study thoroughly what it means, like to measure the temperature, how we can measure the temperature, and all those. And also, what are the exoplanets? Like when the two planets are by side, how the energy will transfer, and how what's the difference between them, and all those. And we need to study also the double stars, like two stars in the side by side, in which how they will attract both each other, and what are their diameters, and how they will what is the distance between them. And also the Planck's law, which is the most important formula to use to find the temperature of the star. Here in this project, I have taken the Planck's law to find the temperature, and also the optical chopper. What is meant by optical chopper, and how many types of optical choppers? Like in this project, I have taken the optical chopper named as MCF02, which is like a wheel type which has only two openings of it. And the last one is which telescope we are using, and how much should be the magnification of the telescope to focus on a particular star like Rigil Kentaurus. And according to my research, according to my study, like The magnification of the telescope should be 30x to 50x. Now I will explain how I have found out how I have written the mathematical formulas of the temperature, radius and the intensity. First of all, finding the temperature, like I have taken the Planck's law to find the temperature of the star, because there are many other formulas that were able to find the temperature of the star, like Wien's law, Planck's law and etc. But there are some unknown values over it. But this Planck's law, we have some known values like some constants, what is the luminosity, and we all know all of this. That's why I have taken this Planck's law to determine the temperature. And coming to the radius, I have taken the formula luminosity of the star, which is 4 pi r square phi t power 4, where phi is the Stefan Boltzmann constant. Like we compared this luminosity, and we divide this luminosity of the star over the luminosity of the sun, where to get the radius of the star, like rigid Kentaurus. Coming to the intensity, I have taken the formula which is the luminosity of the star, but the different formula, which is 4 pi d power 4, where d is the distance between earth and the star which is the 4.3 light years. My experience about this project, like finding the temperature, the radius and the intensity of the star, previously when I was in the undergraduation, I have taken it very simple, like these scientists find the diameter or the temperature of the star like very simple way, like they will compare with the sun and they'll put some values whatever they want and all those. But now when I'm doing my study, like when I'm research about how they will find the temperature, the radius, I was very shocked. Like it's very hard for me to it's very hard to determine the temperature, the radius, like uh, how they will find out, and what values they take, how many days, months, like not days, like maybe somewhat like years to see a particular star, to watch a particular star which is like some light years away from the earth. And after finding out, they'll determine what's its temperature, what's the intensity, what's the diameter. The hurdles I have faced in this project are, the very hardest thing is to find the radius of the star. I have searched the many books, many papers in the library, and some of the formulas over the net, like directly from the PDFs from the internet and all those. But I felt very hard to detect the radius of the star, like how they will find. Even if I found out some of the formulas on finding the radius of the star, but I don't know what are the values of all those, and how to find, like how to find the values to determine the radius, like. And finally I have made some like modifications to some of the formulas, and I have made a method to find the radius by using the differentiation over the star radius and star radius over the sun's radius. That's how I have found the radius of the star Rigil Kentaurus, and it's very approximate to the original one. And I have overcome this type of these hurdles because, like, thinking over again and again how to find, like, what they will use, like some mathematical formulas and all those. I have not only I have searched in this one, I have searched the other formulas as well, like how they will approach in finding, how they will compare one star to the other, like using the double star method, using the exoplanets method and all those. That's how I got an idea in comparing the radius of the sun over the radius of the star. Hence, I want to thank this subject by giving the important project, which is to find the modeling of diameter, intensity, and temperature profile of the star, uh, and giving me a nice supervisor who explains me everything and who stands for me while I was in a tension or worried about the project. Thank you all.